Today, we're diving deep into the world of cyber threat intelligence with a focus on Infostealer intelligence for analytical CTI teams. And let's do a short round of introductions. My name is Fatih Akar, and I am the security product manager at VMRay, leading the advanced threat detection and analysis part of our product line. Before joining to VMRay, I have taken various duties in security departments of large enterprises as a security engineer and security analyst. So we see with the impactful work you've done at the Vertex Project, our audience is eager to hear from you. Could you please introduce yourself and share a bit about your journey?
Sure. Hey, all. I'm busy. I co-founded the Vertex Project a little more than 7 years ago. Before creating Vertex, I spent 5 years at Mandiant and led the team that dreamed up and authored the APT1 report. And prior to that, I spent about a decade in cyber offense for the U.S. intelligence community. And way back in the dark ages, after winning DEF CON CTF, I teamed up with a few friends to run it for a few years.
And let's delve into the challenges, solutions, and the exciting future of cyber threat intelligence. As we embark on this informative journey today, here's a glimpse of what we will be discussing. First, my dear friend VC will start with the CTI challenges and talk about understanding the obstacles and hurdles faced in the CTI world. And also it will continue on to the new approach in the intelligence lifecycle, where he introduces the innovative methodologies and strategies to tackle and also maneuver through these challenges. And then from then on, I will take over and talk about the Infostealer surge and what's happening in the world in that part. So after that, we will have a fun part, hopefully. The integration demo of both of these products will demonstrate live how our solutions integrate together. So Visi, take it away.
Yeah. So yeah, I mean, modern CTI teams face a rapidly evolving set of analytical challenges. Developing actionable intelligence hinges on teams' ability to fuse data from multiple data sources and multiple disciplines into a single narrative that effectively communicate that to decision makers. And when I say decision makers, I don't exclusively mean executive leadership. Every member of the organization's security operations team, from SOC analysts to incident responders, and of course, executive leadership, make critical decisions every day. And in an ideal world, those decisions should be informed by timely analysis. So to communicate effectively, analysts need technology that promotes information sharing while also using permissions to ensure proper controls on confidentiality and integrity, which is near and dear to every analyst's heart. Often these teams are forced to manually collate and integrate data from multiple platforms and have only notes, or worse, a ticketing system to record the results of their analysis. So the scalable recipe is automating the fusion of data from internal and external third-party sources and enabling analysts to record their assessments in a unified model to allow them to report on and operationalize their analysis and allow their colleagues, or often future self, to benefit from their previous work. So we built Synapse, and Synapse is designed to be an analytical workbench and help with each of the phases of the intelligence analysis lifecycle by allowing analysts to automate the things that they're comfortable with and streamline the things that must be done manually. By housing the entire lifecycle in a single system, you end up streamlining the process of turning data into intelligence and intelligence into action.
From now, I will discuss on the escalating threat of the Infostealers and their implications, building on top of what you said. Well, Infostealers are not just data thieves, they're a gateway to ransomware and data exfiltration. They can initiate pathways to more devastating attacks like ransomware. And we've seen a concerning 200% increase in human-operated ransomware since September 2022. So, which emphasizes the importance of tackling this mess, right? And adding to the worry is the commercialization of these threats. Infostealers are now marketed as malware as a service, and this commercial approach makes the malware readily available even for those lacking the technical expertise. Underground markets, especially in regions like Russia, with forums like Genesis, are centers for trading stolen credentials. Furthermore, this scenario has enabled a new wave of threat actors Groups like Karakurt, Strawberry Tempest, and Octopus have emerged, leveraging the booming Infostealer market to threaten global digital security. So in a sense, basically Infostealers aren't just isolated threats, they're gateways to marketable commodities and a catalyst for emerging cyber threats. It's crucial for us in cybersecurity to address this growing concern. That brings us to the evolving cyber threat landscape, pushing us beyond the red line. This represents an escalation in tactics and methods used by malicious actors. And here are some of the key themes you can see as the first of which is the resurgence and redevelopment of cyber threats is evident. And following a temporary pause in 2022, these threats have rebounded fiercely. To the use of Trojanized LLM tools in campaigns highlights the threat actors' evolving sophistication. So on the infrastructure front, there's a growing reliance on WMI and dynamic CTI infrastructures. Malicious actors are utilizing Windows management instrumentation for system profiling, and their embrace of dynamic domain strategies for command and control servers demonstrate their camouflaging prowess. So there's a marked trend of threats, which is like transitioning to ransomware. Beyond just stealing info, there's a clear shift towards ransomware deployment, emphasizing the critical risk that ransomware possesses to entities, right? And adding to the intricacy as the multi-staged payload delivery and anti-analysis strategy. This involves multi-layered authentication methods and sequential payload releases, right? And finally, we witnessed the misuse of EV certificates. The threat actors are manipulating extended validation certificates to give authenticity to their malicious campaigns, covering both Infostealers and the ransomware. So in conclusion, the cyber realm is in a flux with threats becoming more advanced. It's imperative to stay vigilant and forward-thinking. So diving into the updated tactics of the malware, we're gonna subject our talk into the agent Tesla. In 2022, we see it becoming more and more advanced, right? Highlighting is the three primary methods you can see is firstly, the malware uses Excel exploitation. Agent Tesla spreads using Excel documents that exploit vulnerabilities, same as all this from 2017 and 2018. This underlines the significance of regular patching and system updates. Secondly, it's stealthy exfiltration uses variety channels like HTTPs, or including SMTP, FTP, and sometimes even Telegram. This variety shows its adaptability, which raises detection and response challenges. So lastly, the progress in enhanced obfuscation is crucial. Using techniques like steganography and process injection, it hides its presence and makes analysis tricky for cybersecurity experts. So to conclude, Agent Tesla's evolving tactics really highlight the ongoing need for advanced defense and awareness. So let's brainstorm about the countermeasures. So exploring the powerful integration between two formidable products, which when combined, offer an unparalleled and unified front against cyber threats. On the left, we have Total Insight from VMRay. This product brings to the table a suite of analytical tools, first of which is the static analysis, which allows for a quick assessment of a file's attributes without execution. And secondly, as the dynamic analysis, which dives deeper by observing malware behavior during execution. And it also aids in threat classification, helping us to understand the type of potential impact of a threat. So importantly, Total Insight can extract malware configurations and indicators of compromise, which are vital for threat hunting and incident response, right? At its core, Total Insight's primary aim is to comprehend the behavior and capabilities of malware, giving defenders an edge. So it's crucial to note that in today's digital era, we're dealing with these threats at volume, making automation and intelligence paramount. So the middle represents the integration or the bridge between these two tools. It's where the magic happens, basically, combining the strengths of both platforms. On the right, we have Synapse from Vertex. Synapse acts as an intelligence hub, facilitating several key processes. It's not just about data collection. Synapse empowers teams to perform and collaborate on analysis. On the post-analysis, it assists in writing and sharing reports, ensuring the knowledge dissemination, and it collects data to have a holistic view of the threat landscape. So it goes a step further by also enriching this data, adding more context and ensuring relevance. What's exceptional about Synapse is its ability to connect the dots, especially when it gets crucial input from Total Insight, right? So by integrating VMRay's Total Insight and Vertex's Synapse, we're not just stacking tools, we're creating a synergistic solution that's greater than the sum of its parts. So it's a unified front, enhancing our cybersecurity posture and ensuring a more robust defense against threats. As we approach to the demo section, let's talk more about the theme of synergy in intelligence. Our journey begins with the three primary sources of potential threats, right? URLs, malware, and suspicious file all the time. So threat actors consistently release new malware, challenging threat intelligence teams with that. And traditional sandboxes are basically limited, often producing a lot of noisy reports and false positives. So VMRay Total Insight, with its advanced malware extraction, multiple operating system coverage, and API-driven design, efficiently processes large volume of malware samples, converting them into actionable threat intelligence. And threat intelligence extraction capabilities of VMRay Total Insight are basically a verdict on whether the threat is malicious or benign, extraction of IOCs. These are key fingerprints of the threat with individual verdict scores attached. Also, malware classification, determining the type and nature of the malware, and this deep dive into the threat and ensures that we're not just reaching to the threat with reaction only, but understanding and categorizing the threats. As we move towards the demo, let's talk about Synapse. Synapse plays a pivotal role. Doesn't just accept information; it interprets, correlates, and provides context. This integration results in identification of malware groups or families, recognition of threat groups, and organized entities behind the threats, leveraging this Synapse automation technology to speed up response and defense. So in a sense, what we're seeing here is a holistic approach to cyber defense. It's not just about finding threats, it's about understanding them, classifying them, and then using that intelligence to fortify our defenses. So we're on the demo time, and my friend Visi is gonna show Synapse.
Yeah, so we're going to go through a real quick notional demo where you can imagine that we're an analyst, a CTI analyst at Acme Corporation who's been asked to provide some additional context for an alert that's come in. And that alert has come in with sort of the traditional level of specificity that you would often expect to see, unfortunately, from products producing these types of alerts, suspicious file activity. So the first thing we're going to do as an analyst working with Synapse is we're going to fork a new view. And forking a new view, let's see, the alert research. Forking a new view basically allows you to create a scratch space where the data that we ingest and the annotations that we make will be held in a separate scratch space where we can work with it and review it potentially before merging it down into production. So it allows us a little bit of a safety net. So the next thing we're going to do is from this alert, fortunately, the ingest did manage to link this to several other nodes that have been ingested automatically. And one of those is the file bytes node that was part of an email attachment. So we're dealing with an email attachment to Bob Smith here at Acme. And this is the SHA-256 of the attached file. So with the sort of nothing up my sleeve intent here, I can pivot from that file SHA-256 right now, and there are only 3 connected nodes. We don't know anything about it really, file size or anything like that. But what I'm going to do is I'm going to basically use the VMRay PowerUp actions, VMRay sample IOCs to load data. And, you know, demo gods smiling on us hopefully today. We're loading this data in real time. This is an actual demo that we're doing right now. And essentially, we can see that the VMRay PowerUp has responded and actually did create, 4,000-ish edits on 800-ish nodes to basically provide a lot of additional context from their host execution runtime data. Not only that, but they basically had some verdicts and some classifications that they've provided. So they've assessed this file to be malicious and classified it as a downloader, an exploit, keylogger, that kind of thing. And when we expand or pivot to the adjacencies within the graph now, we can see that there are 410 nodes connected. So in the interest of time, we're going to kind of cut to the chase and look at some of the rules that they've matched, but they provide a plethora of host execution data that's super valuable in doing deep dive analysis. So in this instance, we've found that they've classified this file as Agent Tesla. So the first thing that we're going to be interested in is whether or not we are actually, as a company, as Acme Corp, tracking Agent Tesla as a malware family. And we can see that we are. And we're tracking it as Agent Tesla. We have a tag that we're using, which is cno.mal.agenttesla. And so that being the case, that basically confirms that this is likely, a bad attachment and things like that. So the other thing that we're going to want to do probably right away here is to create a new threat cluster. And a threat cluster is essentially that could be an entire topic, but a threat cluster is what we use to group an individual set of activity. So rather than going with like an UNC style name or a temp style name, I'm a fan of naming things uniquely. So we'll name this one Red Tree. And we'll make up a tag for it that is cno.threat.redtree, like here. So in creating this threat cluster, we can also begin to annotate a few of the TTPs and tools that this threat cluster is using. Obviously, Agent Tesla being the thing that kicked it off. Agent Tesla being the thing that kicked it off, we'd want to add that as a tool. And we're obviously fairly certain that this is a phishing attack. So let's add that as a TTP to the newly created Red Tree threat cluster. All right. So moving back to our research view here, we can tag this node as an example, add tags for Agent Tesla. Whoa, I can type today. And Red Tree, because we're associating this node with their diagnostic of it being Agent Tesla and our assessment that it's associated with the newly created Red Tree threat cluster. Similarly, we'll probably want to add that tag to the file node itself. So the other interesting thing is this email message having come in, from this sender address, we would want to potentially load some additional data. So this is where we get into fusing data from our own local and internal sources and show off the power of that sort of fusion. So for example, in this particular case, we're going to load additional additional email sender logs for this address. And it made some edits, which means that there are additional nodes. And when we pivot out from this, we can see that we now have 2 messages that were sent from this particular attacker account. So the conundrum here is not only have we now confirmed that this one file that was attached is bad news, we've confirmed that we've confirmed via fusion with local data that there are potentially other accounts being targeted inside of our network. So for sake of some quick analysis here, we're going to take a look at these 2 users, right? And we can see that they are also the CISO and the VP of Finance. So the other thing that we would normally want to potentially annotate about this threat cluster is that they're using a technique to, as an example, target VIPs. So make that assessment. And then heading back over into the research view, we see that we've now pivoted a few nodes away from our starting point, and we can now kind of walk back along some of these breadcrumbs, adding tags and context, more importantly, context, right, to some of these nodes. So in addition to being Agent Tesla and the Red Tree threat cluster, these are also particularly indicative of the phishing TTP that we've been assessing as we go. So in this particular case, if we then wanted to pivot to the file that was sent by Alice Walker, that was sent to Alice Walker, we can see that it was a separate file. It obviously doesn't have the tags on it, but once again, we can just run the VMRay IOC's enrichment, which will again pull down all of that rich host execution runtime data and allow us to make assessments pretty quickly about what that file is and confirm our suspicions that it's probably going to be Agent Tesla and related to that same threat cluster. So the same email address having sent it, and the fact that the file hit information is also indicative of Agent Tesla means that we can pretty quickly assess that we would want to add these same tags to this node and this node as well. So now that we have all these adjacencies, we can start looking into whether or not any of these things landed. So the DNS requests, which were made when these files ran in the sandbox, are potentially things that we would want to look for in our environment. So when we pivot out from these DNS requests, we can see a couple of FQDNs here, which have been annotated already. We're seeing the results of some other previous analyst's work. And that analyst has annotated that that these FQDNs are frequently used for resolving your own egress IP as part of malware's ability or malware's need to do that. But this cp5ua.hyperhost.ua FQDN has no annotations right now, and we saw it connect out from the sandbox. So the question is this bad news? And again, when we're pivoting and showing the adjacencies, we can see that we've ingested a report previously produced by the Oracle organization. And so let's take a look at this real quick in Spotlight. Spotlight's basically a tool that allows us to ingest open source data and annotate it in line. So we can see that this CP5UA FQDN is annotated here. We can zip directly to where in that report that was mentioned. We can see it was mentioned in the context of SnakeLogger, but adjacent reporting with Agent Tesla and several other things like that. So that makes it pretty likely that this is also bad news and is part of that infrastructure directly. So we would want to tag that FQDN with our tags that we've been using, although not specifically phishing in this one case. And from there, we can look at this DNSA record, which is also very likely associated with the same, and pivot from there to the IP address. So with this FQDN and this IP address, we could potentially want to enrich and show, for example, some DNS logs. So this is, again, fusing data from our own local network. We can see that the newly minted DNS requests that we've just added here are not from the sandbox, but are from real hosts, Alice Walker's PC and Bob's PC. So these are a problem, very likely because these are indicative of the fact that they probably did actually get exploited and this payload landed and called home, or at least tried to resolve those FQDNs. So back to the DNSA record, if we wanted to, we could also tag this node now. And we would potentially want to maybe pull in some additional local data, again, from local data sources like proxy logs and things like that. And we can see that, again, we have actual connections from Bob and Alice's PCs out to this IP address on port 21. And if you recall Fatih mentioning earlier that Agent Tesla is able to communicate over multiple protocols, one of which includes FTP. So we'll probably want to also add these tags to this node. So at this point, walking back upward, we've now confirmed that this file or that variants of this file were delivered to two separate users. And that those two separate users probably did actually open those attachments and that those attachments did actually end up compromising their system. So what do we do now, right, is sort of the next question. And we don't have time to dive into quite all of that. But we can see that we can walk back up here and we've now tagged a lot of these nodes that are associated with these threat clusters. We'll want to also add the tag to the email address that's the sender, including the phishing tag, because that's one of the things that's indicative of the TTP that was in use, and potentially walk our way all the way back up. And if we look real quick, we can see that the CNO threat.redtree tag has now been added to enough nodes that it can form a little cluster of activity, which we could then kick off a further investigation on, because we now have this annotation and this work. So the next thing that I would do as a CTI analyst, kind of closing the loop on this, would be to switch over to this view and make this now become the RedTree investigation view. And now this view was limited to me because I created it, I forked it, but now I'm going to add the remaining members of my CTI team and additionally the IR team, so that they can have access to this data, and we can now kick off an investigation and collaborate over this as the starting point, and potentially invest and pull in a lot of additional data, and even potentially then take some of those host-based indicators, a lot of that additional host execution data, back to the IR team and have them look through other logs and other data sources internally for a lot of that stuff. So thanks for sitting through the demo portion of today's event. I've gone just a hair over time, but I think we're closing the gap on the time. So wanted to basically give a shout out to Fatih. Thanks for the great introduction, and I hand it back to you.
I just wanted to show what would be the information that you could actually get from the VMRay's console right before we close up. As we said, VMRay Total Insight provides the static analysis and dynamic analysis capabilities. As you can see from an agent Tesla sample, we've seen a lot of different malicious behaviors throughout this dynamic analysis, where when we go and drill down to a dynamic analysis, we will see a lot of things regarding this processes and all the malicious activities that are mapped to a MITRE ATT&CK framework, and also the IOCs where you could use them to do all kinds of powerful pivoting activities that we see just recently shown with the scores attached to them right next to them with the files, IP addresses, and all kinds of other stuff. I'm sure there's a lot of things that we can discuss in here on going through the demo of VMRay Total Insight, but just to do the last remarks. So as we wrap up, remember our holistic defense, merging. Okay, I'm just wrapping up. Remember our holistic defense, merging VMRay's robust malware analysis with Vertex's Synapse. CTI enablement. We're proactively tackling Infostealer threats, not just reacting. So this powerful combination not only boosts our defense, but also sharpens our threat insights. And with our seamless integration, we ensure quicker responses and smoother operations. So yeah, in a world of cybersecurity, knowledge isn't just power, it's our primary line of defense, and synergy between Total Insight and Synapse ensures we're always one step ahead.
Thank you. Very good for a very good presentation. I think we have two questions, so if we can answer them quickly, I think it's good. And how important is to track malware, as the majority of the attacks are maybe indiscriminate or opportunistic, random, non-targeted phishing attacks?
I mean, yeah, I can jump in and discuss that a little bit real quick. I mean, ultimately, the true question is how you want to cluster those things and whether or not you want to deal with those as targeted threats or as opportunistic threats, right? So there is a lot of opportunistic targeting that goes on, but the real important part is making the distinction between those. And so once you decide to cluster up a set of activity and make the assessment that it is opportunistic, you could certainly potentially downgrade your level of attention that you pay to that thing versus a more targeted threat, which would pose a bigger risk to the organization.
Excellent. And there is thanks for answering that in a concise manner. Very last one: does VMRay do threat attribution?
Currently, we do threat classification. We have our own YAR rules that our labs team are currently writing and continuously shipping to both cloud and on-prem customers. And these YAR rules are also enabling us to do the malware configuration extraction. But currently, if the user wants to do the attribution to a threat actor or group, they need to go through the route of what Wissy shown a couple minutes ago. So it has to be combined effort.
And also potentially join in data from other data providers, right? I mean, one of the themes that's been talked about, I've been listening in on a couple of the other talks, is that it's super important, to pull in data from multiple providers, multiple sources, and use that in a fusion kind of concept to confirm.
Excellent. Well, this is a great way of wrapping up the session. Thank you so much again, Fatih and Visi, for your presentation.